Hello everyone. This is Jnanada. I am from Team Think Tank and we are presenting our product Whisper AI. The objective of Whisper AI is to be an agent that can automatically transcribe audio and video content into text. This agent will be part of layer 2 offerings in the Solidus marketplace, supporting various layer 3 applications like intelligent chatbots, document intelligent apps, and many more. What is the motivation of Whisper AI? As you know, the consumption of multimedia content has become an integral part of our daily lives. Whether it's watching a tutorial, listening to a podcast, or scrolling through a photo feed, multimedia content keep us informed, entertained, and connected. Also, there are manual transcription challenges. First and foremost, transcription is incredibly time consuming. On average, it takes about 4 to 6 hours to transcribe 1 hour of audio, which can lead to fatigue and decrease the overall productivity. Whisper AI can help other products to reach broader audiences, and eventually it will get better user experience with accurate and timely subtitles.
Hello everyone, my name is Prince and I am going to talk about the tech stack and the other things and the demo for the Whisper AI product. So we have basically three components to it. One is the AI model, the second one is how the APIs are built, and third one is we have contained everything into a Docker. So for the AI model, which the Whisper AI product has used, is called as Whisper. So it's an open source AI model which is provided by the company called as OpenAI, and its job is to transcribe audio and video content into text. Now this implementation which we are using right now for the particular model is in C++. So there is a whisper.cpp repo where we have used it comparatively because the implementation is in CUDA and C++, which is basically essential for making sure the model is very fast and effective. There is a small model size, so the GPU memory taken here is also very less. I will go through the numbers later. So there is an API, the fast API implementation in Python, where it was done to make sure the visualizations about the APIs are all very clear. Then there is Docker, which we have made sure that we provide it according to the documentation which was provided by the Solidus hackathon resources. So let's go through it. So the design is essentially very similar, which was given to us. So there is a manager of let's say the different types of requests which you are going to receive, and then we put them into the threads. So each thread will try to process a task. Let's say each of the tasks would be something like a API call for processing a audio or a video file. Then there is the model, so which will basically take up the task one by one, and then it will essentially submit the results to the local webhook right now, and it will save, let's say, the output text files as well as the videos which got generated throughout the process into S3. So we also use S3 for getting our data. So essentially when the user uploads an MP3 or a video file, we essentially use S3. So the user has to, or let's say the marketplace has to have the access of S3, so that we take up the data from there and then we let's say run our content through it. Meanwhile all this is happening, there is a database which gets let's say the database is getting filled through, where for each task we are noting down how much time it took, as well as how many requests we have processed. So let's go through the demo. Now what I would like to share is the demo API. So this is the API right now, which is hosted at this link. Now I have accessed the API through the docs, which is basically the fast API way to present the APIs. So as you can see, let me refresh this. So as you can see, this API is currently active in our browser, and what we have is, let's say, the endpoints which are basically given to us. So one is call, second one is the result, and third one is stats. There is an internal API call which is again to the local web, which we'll be seeing in the background. So let me go through the call endpoint. So if I go to the demo page of the hackathon, there is the demo link which is present here. And then if you scroll down, then there is a sample payload for the call. So this is the current, let's say, method which we are using, whisper it. And then the payload would be something like an data underscore S3, which is like the S3 link for the MP3 file. Now this particular file is currently in our S3, which is here. So if I go to this, S3 page, so you can see this MP3 file is present here. Now let's call our endpoint. So I'll just open up this call and let me click on this try it out. Now I can give a sample user ID. Now this can be any user ID. The user role is also made in the latest documentation, so that's what we have added right now. Request area, and then there is a marketplace token. Let's go through it. So the important part of it, so the method which we have is whisper it, and the data underscore S3, which is again defined, is the link which we want to use. So this is the link SS3 and then GFK MP3. So I think before even calling it, let me play this MP3 file. So I have, I think, somewhere in my local systems.
And so, my fellow Americans, ask not what your country can do for you, ask what you can do for your country.
All right. So this is the MP3 file which we have provided into the S3 bucket. Now for this particular API, let's call this endpoint. So which is again the current endpoint, and then let me process on the execute. So as you can see, when we do a request, so the response is immediate, which is basically with the status message of 001, which is kind of pending right now, which is reason. And then we have the task ID, which is given in the response. So this is very important field. So if we get this task ID, then we can actually access this task after a point of time when the process has completed. So let me scroll down. Now the response was successful, and let me see the result. So here it's also, there is a result endpoint. Also in the background I will go through. So currently I will just enter this user role and ID for the post request of result. And here I will put in the task ID which I had gotten from the first call request. So now I feel that the server should have processed it. We have used a very tiny model here. So the video, or let's say the audio file, was also very small about a particular statement. So let me execute this and see if, if the task is over. All right. So as you can see, we have now called the result API, and then we are able to get the response. So the data type here, which we received for this particular task ID, which we gave, is hybrid. And then the payload is also defined, which is basically the result. Now the result is in language of English. So the text which was produced by the model is in English. So that is what it is telling. If it is any other language, it will basically tell that particular code. Then there is a transcription. Now for transcription, what I really want is, for each statement, I want a timestamp. So here is the end-to-end, let's say, text which was there in the MP3 file which we have heard. So it was, and so my fellow Americans, ask not what your country can do for you, ask what you can do for your country. So as you can see, for each timestamp there is let's say there is the text which basically will allow the user to even do some let's say they can basically, they are open to do anything. I will just show one use case which we have done right now from here. So so now at the end, now these are all the timestamps. At the end there is one more thing which is called as S3 path. So this I have added, which was not there in the documentation, but the data type is hybrid. So basically we mentioned both the let's say the MP4 file as well as the about text. So if I go and check this particular MP4 file, which I will just showcase it after a while. Basically after going through the result API. So this is basically the success message which we have received. So now if I just do a stats, so currently if I just do a try it out for the stats, so this is the like the final API which was given to us to be implemented, and let me run it quickly. All right, yeah. So once I execute it, it's basically telling me there are a number of success responses which were won. There were some failed requests also which you have tried earlier, tried it out, and that's why the database contained those particular requests, right? So yeah, again, like this is a sample which we have implemented for the stats API. So now let me go back to the S3 path, which is the result actually, which the developers can use, or essentially they can get an idea of what you can do with this particular response. So if I go through my S3 bucket, and now if you can see, this is the input right now, and if I refresh it, hopefully there is a so there is a result MP4 file also. So let me download this one. So it's getting downloaded. It's downloaded. Awesome. Let me go through my so this is the new file which got downloaded right now. Now let me open this. So if I open this and maybe
And so, my fellow Americans, ask not what your country can do for you, ask what you can do for your country.
All right. So this particular MP4 file was generated. It was containing the text which we have generated, and then it was also containing the animation for each text when the user spoke that particular word, right? So now this is a very detailed transcription, right, which is kind of useful for the other agents, also for any other agent which can use this particular data. So I think I have gone through all the API calls. Let me go to the quick overview on the code base. So this is the code base which we have hosted into the AWS machine, which is like a free tier machine. Now in this particular machine, I think the essential things are, let's say, the engines which is there for the accessibility of this particular API. And then there is something called as the build Docker script, which was given to us, I think, which is like a sample code base. So here I would say it's basically going to the Docker file and trying to build that particular Docker. And this is the Docker which we have built and given to the, let's say, given in the README file. Now after the Docker is built, there are some commands which we have mentioned to run that particular Docker, and currently the Docker is running into our AWS machine. And if I see it right now, so this is all 11 hours up. Now one important thing here is, let's say, the logs right now are generated dynamically. So if I go to the logs, I can just do a let's say the tail on the app logs. As you can see, the details about the files are also there, so it's getting successfully uploaded here. There are messages which are here and there. Now I think one important thing was the endpoint to the marketplace. So here also, if I go and check this one, so we get I think we get a 200 response because we have posted a, let's say, final content to that particular local webhook receiver, right? Now the Docker file is present in the particular repo, right? And it's all hosted and basically it's into the GitHub right now. And there will be some few changes based on, if we want some developer changes to the API calls, we can basically do that. There are some, create DB and other things which are also there, which is basically entering our data set, and then, it's basically filling our database. So that is all there. All right. So I think what the model is about, I will just go through that. So the model is basically hosted here. So it's again like into the Hugging Face repo, but essential point is this is an open source model. So we can do a retraining on it, or we can use some kind of, let's say, machines to train some good models, and then we can host our own models, right? So this is a very open source model. There are some models which are basically described here, which is tiny, base, small, medium, and large. So for let's say tiny, the disk space uses 75 MB, and the memory in the GPU would be, let's say, 270 MB. So while running, it will basically take up this much space. So in the AWS machine which we have right now, so it's the tiny model which is hosted. We have not hosted the large model right now, just because it's a free tier machine. The code base is also here. The other thing is, let's say, the future scope of this particular project. So essential point is, this model is currently open source. So now what we have used is, let's say, we are giving the API calls to MP3 files, and let's say with the video files. So now it's basically running the transcription model. Now other things are, let's say, is it very efficient or is it very fast? So according to our benchmarks, this is the fastest model into the particular space of transcription. So the OpenAI model is not only efficient, but it's also really fast in terms of, let's say, if I talk about the implementation, which is done by this particular, let's say, so that's done by this particular repo in GitHub, which is the whisper.cpp. So it's all built in C++, and then we are using in background. And also it can also use CUDA. So once we have a CUDA enabled, let's say, server, we can actually compile a new Docker with respect to CUDA. So that Docker, which I want to essentially showcase here, is this Docker file. So currently we are using this Whisper CPP, but we can also use the CUDA version of that particular Docker. The other thing is, let's say we have the text right now, we have all the, let's say, a sample demo for which, we have showcased the animations on that particular text. But let's say there is more things to do on it. We can essentially take that text and summarize it up. Or, if there is a podcast happening, what we can do is basically collect those text and save them into a text file. One thing is, we can definitely make a subtitles SRT file for the user, but also more finally, we can also generate some key moments which are there in the podcast, or let's say a video where the user is speaking, let's say, or he is giving a presentation, right now. So what we can do is, we can summarize this text. We can basically analyze how user is speaking, how user is pacing himself, right? So those kind of outputs can also be generated by, if you have all these textual data. In multimedia, let's say, field, there are various industries which can basically use this model, and this was the gist of what we are currently trying to do. Now I think, let's say, I have already addressed the let's say, I think my partner has already addressed some of the challenges which are there in the manual transcription world. So now this particular solution replaces that, and it's also a scalable solution because the model size is also very small, right? So it's like a tiny model right now used here, which works on some particular accent, but I think more and more accents when gets trained into the model, so the model size gets bigger, right? So in that way we have to train it up, and let's say the maximum size which we can have is basically 2 GB, right? And the limit which was given to us, maybe I think it's 12 GB, so it's well over, I think, lesser than that particular limit right now. The other thing is, once you have the text from this any video, right, it enhances the accessibility, right? You can reach your audience throughout the network. So I think one example is this Mr. Beast video. So if you can see that, like here, they have given the subtitles in Hindi also. So now they are able to reach even the Indian audiences. So that is one way to think of it. The other thing is, let's say, so this particular solution is an API, right? So anyone can use it. So any document generation apps or other apps, something like the layer 3 agents, so they can also use this particular layer 2 for them from the marketplace. And basically what we will be able to do is essentially improve that model time to time whenever there are lots of API calls. All right, so I think that was the whole demo for the product, and thank you for giving us the time to listen for this particular demo. So thank you.